Before we start this set of problems, let's remember that the integral of 1 over u du is equal to ln u. That is ln absolute value of u. Or, if we have something of this form, if we have a derivative in the numerator and the function that it's a derivative of in the denominator, this is what we call a log integral. This is log of the denominator. So if we see some sort of rational expression, we look for that. We check to see if the numerator is the derivative of the denominator, and then we know that we have this type of log integral. All right, in this case, we're in this 1 over u situation. We can do a u substitution, put u equal to 5x plus 1. The derivative of the denominator is 5. It's just a constant. We're missing the constant. So we're just going to really multiply by 1 over 5. But let's just do the u substitution, and that'll come out. So du is equal to 5 dx. And 1 over 5 du is equal to dx. All right, now we're ready for the substitution. So instead of dx, we're putting 1 over 5 du. And here we have 1 over u. All right, so this is equal to, this is what we have here, this situation. This is equal to 1 over 5 ln absolute value of u. All right, so we always have to substitute back for our x, and so that's 1 over 5 ln 5x plus 1. In number 2, we have that situation where we have a function in the denominator. Let's say we'll call this f of x. The derivative of the denominator is 21x squared. We're just missing the 21. We basically have the derivative in the numerator without the 21. All right, so we're going to put u equal to the denominator. And du is take the derivative 21x squared dx. All right, and solve for the x squared dx. So there's that 1 over 21 that comes out in front. You could skip this u substitution and go straight to the answer, which is 1 over 21 ln denominator and absolute value. All right, but we're doing the u substitution, so let's continue here. So instead of this x squared dx, we're putting 1 over 21 du. And here we have 1 over u. All right, so we know that this is ln absolute value of u. Okay, so that's, now put x back into the expression, and u is 7x cubed plus 1. Number 3 is a simple u substitution. Look at the inner function, ln x plus 3. The derivative of ln x plus 3 is 1 over x. And here we have a 1 over x in our expression from that x in the denominator. So we're just going to do a simple u substitution. We'll wind up with the integral of u to the 10th. So we'll do u equal to the inner function. And du is 1 over x dx. Okay, so we're ready to substitute now. For 1 over x dx, that's what we have here. This is 1 over x dx. We substitute du. And here we have u to the 10th right here. So this is just a power rule. And now let's put x back. U is ln x plus 3. Number 4 is also a u substitution similar to the previous one. If we put u equal to this inner function, ln x, then du is 1 over x, and we have that right here. All right, so we're going to put u equal to ln x, and then du is 1 over x dx. Okay, so we're ready to substitute. All right, so we have the integral, and here we have, instead of 1 over x dx, that's 1 over x, that's dx, we're putting du, and we have 1 over u cubed. Now, what about these x limits? Okay, we have to change those to u limits, so let's do that. So we're going to substitute e, and ln e is 1. And here we'll substitute e squared, and ln e squared is 2. So this turns into the integral, the u integral between 1 and 2. All right, so this is u to the minus 3. Let's just do a power rule here. Add 1 and divide by the new exponent. And now we'll put in those limits of integration, 1 and 2. Okay, so first let's substitute in 2. So there we have minus 1/2 and 2 to the minus 2. I'll just write it like this. And now we're going to subtract minus 1/2 and 1 to the minus 2. All right, let's just simplify this. So here we have minus 1/2 times 1/4 plus 1/2. Or minus 1/8 plus 1/2, which is 4/8. Okay, so this simplifies to 3/8. It's a little hard to recognize that number 5 is of this form, this form that yields a log. All right, but if we rewrite it, let's write it like this. That x to the 3/5 in the denominator, we'll write it as x to the minus 3/5 in the numerator. Then we see if we take the derivative of the denominator. Let's see, let's just look at this on the side. The derivative of 1 plus x to the 2/5 is derivative of 1 is 0, and the derivative of x to the 2/5 is 2/5. X to the 2/5 minus 5/5, that's minus 3/5. So you see we have that right here in the numerator. Okay, so we're going to put with u equal to the inner function, just a regular u substitution. And we see that u prime is equal to 2/5 x to the minus 3/5 dx. And let's solve for what we have. This is what we have in the integral, so multiply both sides by 5 over 2. So we have 5 over 2 u prime is equal to x to the minus 3/5 dx. All right, we're ready to do our substitution. All right, so for this, and this, we're substituting 5/2 du. Actually, let me not write this as u prime. Let me write this as du, like we usually do. And here we have 1 over u. I'll write that as u to the minus 5. Getting ready to do the power rule, so now we're ready for the power rule. That's u to the minus 4 divided by minus 4. And now just put x back. So we have, let me multiply these, minus 5 over 8. And we have 1 plus x to the 2/5 to the minus 4. Number 6, we have a rule for integrating functions, exponential functions. And let's just remember that the integral of a to the x dx is equal to 1 over ln a to the x. And it just comes from the fact that when we differentiate a to the x, we get ln a to the x. And that's why we have to multiply here by 1 over ln a because the ln a is missing. All right, so just applying that formula, we have 1 over ln 7 to the x. Here we have a simple u substitution that will lead us to the integral 5 to the u, because we'll make u equal to that inner function. And we see the derivative, it will be 4x cubed, and we have the x cubed over here. All right, let's solve for x cubed dx, what we have there. So 1/4 du. That's the 1/4 that's going to come out in front. Okay, now let's substitute. Instead of x cubed dx, we're going to write 1/4 du. And instead of 5 to the x to the 4th plus 1, we have 5 to the u. And we saw before that the way we differentiate, the way we integrate an exponential is according to the following formula. The integral of 5 to the u is 1 over ln 5 times 5 to the u. And now we'll just put back our x's. And we have 5 to the x to the 4th plus 1. This is actually of the form that we are looking for, a function in the denominator and its derivative in the numerator, maybe missing a constant. The derivative of this denominator is 5 e to the x, and here we have e to the x without the 5. All right, so really just we know from the beginning a 1/5 is going to pop out. It's going to be 1/5 ln denominator. But I'll do this with the u substitution. Du is equal to 5 e to the x dx. Remember, the derivative of e to the x is e to the x. All right, so here's that 1/5 du equal e to the x dx. All right, so instead of e to the x dx, we're putting 1/5 du. And here we have 1 over u. So this is equal to 1/5 ln absolute value u plus a constant, and now put x back. U is equal to 2 plus 5 e to the x. And then number 9, we're also in that same situation pretty much. Function in the denominator, derivative in numerator. Okay, let's see, what is the derivative of x squared plus 4x plus 7? All right, so that is the, let's say, let me just say that the derivative is 2x plus 4, which is the same thing as 2 times x plus 2. All right, so we have the x plus 2 up here, we're just missing the 2. Okay, so we are pretty much in this form. Denominator and the derivative without the 2 in the numerator. So again, we're going to put u equal to the denominator. We're going to get a 1 over u integral. du is 2x plus 4 dx. And we're going to write this as, just factor out the 2. Okay, let's divide by 2. Okay, and now we're ready to do our substitution. So instead of x plus 2 dx, we're putting 1/2 du. And here we have 1 over u. So that's our log absolute value of u. Now put the x's back. U is x squared plus 4x plus 7.